All right, welcome back. So we first found this and we did the slopes. We got the top segment, the bottom segment, it had slopes of 0, and the legs, as it were, ended up being not parallel to each other. We want to test to see if it's isosceles trapezoid by looking at the distances of the diagonals. So that'll be where we go to next. Diagonal distance. So our diagonals are going to be AC and BD. Trying to find the distances of those diagonals. And so for AC, it is 7 units by 4 units. For BD, it is 7 units by 4 units. So it looks like we're getting the same things here. The same materials are going in, so we suspect these will be congruent. 49 and 16 together makes 65. Okay. Now the diagonals are congruent, and that's confirmation. We could have just as easily done the sides. So if we did legs with distance, we would get that AB and CD, and those values would come out to be 2 squared and 4 squared. So either one of these two would be sufficient. We wouldn't need both of them. But it's good to know all the properties, so we just want to practice in different ways. So the slopes tell you the trapezoid because one pair of sides parallel. So that is a fact. And then either one of these distance options would tell you isosceles trapezoid. And your reason would be, well, either the legs are congruent or the diagonals. You would not need to do both, but I wanted to show you either of them. So hopefully that's centered up for you, okay? So you just pick one of those reasons why it would be isosceles trapezoid, and this would be the exact reason why it's a trapezoid. Okay, we're moving on to a segment called the mid-segment. It connects the midpoints of the legs. So this is the midpoint of the leg on the left, this is the midpoint of the leg on the right, and the mid-segment connects those two. It looks like it's the average, and it is the average. The average of the bases. So let's go ahead and see if we can figure out these last couple problems. On this page, so the upper base is 14, lower base is 27. Want to find the length of the mid segment. Segment is going to be capital M equals 1/2 of 14 plus 27. And that's going to give us M is 1/2 of 41. And that's going to give us M equals 25. next problem, it says that the upper base is 29. The mid segment is 20. And it wants me to find the length of the lower one. So I'm trying to find that for x. Now the way I've drawn my picture doesn't really make sense because it's telling me that 29 is the big one, but I can kind of tell this is going to work out. So I'm gonna turn my picture over instead of change my values. So I'm going to make it this shape. Okay, and so in this case, we're going to have that 20 equals 1/2 of 29 plus x. It's going to give us that 40 equals 29 plus x. And then x is 11 centimeters. Pretty good, pretty good. All right, next page. We got to talk about kites now. Please say kite. Kite. In a kite, we're going to have two pairs of consecutive sides congruent. Is a kite always a parallelogram? No, but it could be. Is a rhombus a kite? Yes. It just meets our criteria twice. It's got, instead of just having one pair, like a kite does, I'm sorry, two pairs of consecutive sides, it actually has four pairs of consecutive sides. One of them here, the second one, the third one, and the fourth one. So it actually has more than two pairs of consecutive sides congruent, but it definitely has two pairs of consecutive sides congruent. It has four instead of just two. Is the square a kite? Answer is yes. Now, kites that are not parallelograms, we often draw this way, with the bigger legs down here and the smaller legs right here. So one diagonal is the perpendicular bisector of the other. You'll notice that's going to make this segment on the bottom congruent to this segment on top. We have one pair of opposite angles that are congruent. We have one diagonal that bisects one pair of opposite angles. So this is, it gets a little bit challenging, but the ones that are opposite, the angles that are opposite of each other, that are congruent, are flipped with the ones that are bisected. And then one of the diagonals is the perpendicular bisector of the other, but we can clearly tell that this diagonal does not bisect this one. If kite ABCD with all these lengths, what can we do with it? So let's go ahead and say if AC is 8, well, that's going to make each of these 4. These will be the ones that are bisected. And if those, okay, and then we're also given that AB is the same as BC. Okay? And we're also given that CD is the same as AE. Okay? And we're going to try to find exact measures for everything. So I can see in this triangle I've got, oh shoot, these are perpendicular. Gives me a triangle that's got a 4 on the side and a 3 on the side, and so we've got a 5. So that's a Pythagorean triple. It's going to mean that AB equals 5. For DB, a little bit more challenging. I've got this triangle here that's 4 by 12. Oh, and I have the 12 in the wrong place. 4 by 12. Let's just start that over. So I got a right angle, I got a 4, I got a 12. I can solve this a couple different ways. I could look for a scale factor of 4 and then solve this triangle that's 1 squared plus b squared equals 3 squared. I could go from there. Or I could just do the bigger numbers and do 4 squared plus b squared equals 12 squared. So I got a couple different options here. The numbers aren't too big, so myself I might do the blue, but I want to show you the way in red. Either way, you can use Pythagorean theorem. So it's going to give you that 1 squared plus b squared equals 9, which means that b squared equals 8, which means b equals the square root of 8. That means that down here in my triangle, like my square root of 8 side, which I have to multiply by 4, you get 4 square root of 8 on the outside. That's not fully simplified, since an 8 is a 4 and a 2 and a 2 and a 2. So my 4 over 8, I'm sorry, my 4 root 8, which is what I have for dB, is an equivalent expression, but it's not fully simplified. I need to pull out a pair of 2's to multiply with my 4, and all I have left is on the inside is a root 2. That's going to give me a final answer of 8 root 2. Okay, we could have done the same exact thing. Oh shoot, that's not what dB is. That's what d to the middle is. We need to add 3 to that. So you have 8 root 2 plus 3, and that's what dB is. These have a plus 3. All right, good luck with the rest of the 6.6 homework assignment. It's good to see you. Welcome back. Goodbye. Merry Christmas. Happy spring break.